All right, so we're going to start off this week looking at our second conic section, which is the ellipse. There's 4 different conic sections. We've already done the parabola. Today we'll focus mostly on the ellipse and a little bit circle, but only about a minute or 2, not much at all. And then tomorrow we'll finish conic sections with hyperbolas. Don't forget, all the homework for conics is in the packet. Okay, so tonight and tomorrow homework, you don't need your book. All right, so each conic section starts with the definition. It's a collection of points in the plane that, and then satisfies something. So with a circle, everything is based around a center point. A circle is a collection of points in the plane that are all equidistant from a point we call the center. Well, ellipse is similar, right? Except instead of just having 1 point, there's 2 points. And if you measure the distance from any point on the edge of the ellipse to each of these special points and add them up, you will always get the same number. Okay, and I'll show you a picture of that and then kind of interactive move some stuff around, and you can kind of see this definition as an image more than just words. Okay, so in an ellipse, you've got 2 special points. And if you measure the distance on the edge of the ellipse to both of these special points, add those distances together, you will always get the same number for a specific ellipse. Okay, so let me show you as a picture. So the 2 fixed points that I reference here, I'm calling B and C. Okay, they don't have to be called that, that's just what they are in this picture. E is a point that I can drag around the ellipse. In this particular ellipse, if you measure the distance from any point on the edge to B, and that point to C, and then add the 2 distances together, you will always get 17.3 in this particular one. Oops, I can drag it. So notice the 2 line segments change. Like right now, EB is really, really short. It's 1.7. And EC is very long. Okay, but no matter where I drag them, if you take those 2 numbers and add them up, you'll always get 17.3. Okay, you can check it, but that does add up to 17.3. And this 17.3, that's a calculation. That's not just me writing an equation. It's actually taking how long is EB, how long is EC, and it's taking those 2 numbers and add them together. So if that number was changing, you would have seen the 17.3 change. Okay. But it didn't. So those 2 points, like sometimes what I used to do, like if I had like a bulletin board or something with paper behind it, is you could take and put 2 points in a bulletin board. Okay, take a loop of string, okay, or something, put it around those 2 points, okay, pull it tight, and then, I don't have enough room, but the path that I'm tracing right now would be an ellipse. Those 2 distances would always add up to be the same. But that's how you draw an ellipse. Just put in 2 points, put a loop of string around it, stretch it tight, and then trace it around. As these 2 points start to get closer and closer together, what do you think happens to the shape of the ellipse as B and C move together?
It's more vertical. Stretches more vertical.
Yeah.
Elongates.
It elongates? Well, actually, the further apart you put B and C.
It'll go this way.
Yeah, so it starts to change a little bit. And eventually, if B and C were right on top of each other, it would turn into a circle. Okay? If you put those 2 points at the same spot. So ellipses and circles are kind of similar. So those 2 points that I had labeled B and C, those are called the foci. That's the plural of focus. Okay, you don't say focuses, you say foci. Okay. Now, in an ellipse, we have two axes. If I go back to it for a second. That line that I put right there, that's one axis. That line that I'm trying to put right there, that's another axis. One of them is always longer than the other, okay, in an ellipse. So the longer axis, that's called the major axis, and the shorter one is the minor axis. What I've done in this diagram is I labeled the 2 points. I had B and C before. I just called them F1 and F2. Okay, stands for focus 1, focus 2. Don't worry about V1 and V2 yet. I haven't told you what those are. So for now, just put that. And P is just any point on the ellipse. And there's the definition of an ellipse as an equation. Okay, so I wrote it out in words for you, tried to show you it as a picture, and there it is as an equation. The distance from the point to F1, that's the first dotted line, plus the distance from the point to F2, that's the second dotted line, always comes out the same. So if you notice, the major axis goes right through the foci. Okay. And that's what I just said. If you draw a line right through the foci, there's your major axis. The major axis goes right through all the important stuff. It's going to go through two other points in a minute, which I erased, but I'll name them in a second. If you connect the two foci and find the midpoint, that's called the center of the ellipse. Okay, so what does that really mean? Well, if you drew in that line segment from F1 to F2 and found the halfway point between F1 and F2, that's the center. Okay, so that's important to remember. The center is always halfway between the foci. So if you know the foci, you know the center. You just have to find halfway between them. I'll just label that C for center. Okay. If you draw a line through the center, but perpendicular to the major axis, okay, so in this particular case, going up and down, that's the minor axis. So the minor axis goes right through the center, and it is perpendicular to the major axis. Right? And the 2 points that I erased, those are called the vertices. That's where the major axis crosses the ellipse. So here and here, V1, V2, vertex 1, vertex 2. Okay, so vertices are where the major axis crosses the ellipse. So major axis goes right through all the important stuff. Okay, and I think that's most of the vocab. Just kind of get all that stuff out of the way up front. Any questions on those terms? Major axis, minor axis, foci, vertices, center. I think that's it. All right. So there's not as many cases for an ellipse as there are for a parabola. Parabola, there were 4 cases: opening up, down, left, or right. For an ellipse, there's only two. Either your ellipse has the major axis horizontal, or the major axis is vertical. Whichever way the ellipse is longer, that's the major axis. Horizontal major axis, I'm sorry, vertical, horizontal. So we'll start with the horizontal case. So like we did for parabolas, we're going to use a chart in the packet, and that's what I'm looking for. Okay, so there's a chart. We'll get to it. It's on page 394. So this particular one we're going to look at, this is where the center is at the origin. In fact, every problem we do from now, the center is going to be at the origin. And the foci are C units away from the center. Okay? C units to the right and C units to the left. Okay, so what I like to do is just kind of keep track of what's what. It's fine to write it that way, but for me, if I can remember C is the distance from center to the foci. Okay, the major axis is horizontal. And A is how far away the vertices are from the center. A units right, A units left. Everything is symmetrical. So if one vertex is 7 units to the right, the other vertex is 7 units to the left. So A is the distance from the center to the vertex. Notice I didn't say from the origin to the vertex. Technically that would be true here because the center is at the origin, but it won't always be. And that's the equation. So the equation is x squared over a squared plus y squared over b squared equals 1. So we mentioned this thing about c, but notice it doesn't appear in the equation at all. The only thing that appears in equation is an a and a b. I didn't mention anything about B up above. Well, a couple things about A and B. First of all, A is always bigger than B. Always. So if I give you two numbers and you're not sure which one is A, it's the bigger one. So A is always bigger than B. And they're both greater than 0. So A and B are never negative. Now, the other thing is we don't know what is B. A is the distance from the center to the vertex. C is the distance from the center to the focus. Well, this formula right here tells you how to get B. It looks kind of like the Pythagorean theorem, but it's definitely not. It's c squared equals a squared minus b squared. That's an equation that's always true for an ellipse. So, as long as you know 2 out of 3 of these letters, you can find the third one. Any questions on the equation or the inequality or the formula that's below it? Now, I'm going to come back. You don't have to write this next part down. I just want to show you it before we move on. Notice how this equation looks. You got that one. This is going to be the other one when we get to it. Did anyone see the difference between that one we just wrote down and this one?
A and B.
That's all that happens. You swap A and B, you change your ellipse from horizontal to vertical. It's the only difference. Okay, but well, everything else is pretty much the same. All right, so let's try an example with this one. So to graph an ellipse, sometimes it's helpful to find intercepts, but not always. So if you could find all your intercepts, that might make sketching the ellipse easy. But keep in mind, you could have an ellipse like this. It doesn't have any intercepts. Okay, so ellipses don't always cross the axes. And actually, this I already gave you earlier. Okay, A is the distance from the center to the vertex. This one I didn't give you. You might want to write that one down with the other two. B is the distance from the center to where the minor axis hits the ellipse. So what does that mean? B is this. That's B. The distance from the center to where the minor axis hits the ellipse. A is this. Distance from the center to the vertex. And C, I already gave you that one. That's the distance from the center to the focus. Center to minor axis. Okay, any questions on what A, B, and C are? Okay, in any problem, they'll always give you a way to find 2 out of 3 of these. A lot of times, they're going to tell you C, but then you're going to have to do a little work to get A or B, okay? Because C is not actually part of the final answer, but you're going to need it. So let's see if we can find an equation of this ellipse. So the center is 0, 0. The focus is 3, 0. And the vertex is negative 4, 0. Okay. First thing you should always do, if you're not sure where to start, is write down A equals B equals C equals. Find those 3 things, or find as much as you can. Out of the A, B, and C, is there any one of those I have enough information with what they've given me to find? Which one?
For A?
Yeah, I do have enough information for
The center
A.
and the vertex.
It's the distance between the center and the vertex. So how far apart are the center and the vertex? 4. So A is 4. Do I have enough information to find anything else? C. What's C? 3. How'd you get that?
The distance between the center and the focus.
C is the distance between center and focus. One of them's at the origin. One of them is 3 units to the right. That's a distance of 3. So now we've got A and we've got C, but the letter we really need to write the equation is B. We have to find this. Okay, so we've got x squared over a squared plus y squared over b squared equals 1. Okay, and what's the equation that has a, b, and c in it? Kind of looks like the Pythagorean theorem, but it's not. Yeah. C squared equals, and just make sure we get the order right, a squared minus b squared. A squared minus b squared. Okay, let's fill in what we have, and we're going to find b. Brandon, what's c squared?
3. Or, no, sorry, 9.
Yep, 9. A squared, 4 squared gives me 16 minus b squared. Okay, subtract 16. We get negative 7 equals negative b squared. When you have a negative on each side, you can just cancel it. So 7 equals b squared. So how would you get b? Yeah.
No, I just have a question, but you can finish.
Okay, what would be my last step to get b?
Square.
Yeah, take the square root. And really, we don't even need b. If you look at the final answer, we need b squared anyway. Okay, so we know b squared is 7. Okay, so my final answer would be x squared over 16 plus y squared over 7 equals 1. And that's the equation of the ellipse. If you were just looking at that, I know we haven't learned the other one yet for when the ellipse is vertical, up and down, but wherever the bigger number is under, that tells you the direction the ellipse goes. If the bigger number is under x, the ellipse is going to go in the x. If the bigger number is under y, the ellipse goes along the y. Okay? Yep.
And that would be like the final product of the answer. You don't do anything with that answer. That's like that's it.
That's it. Yep. That's it. Even as far as rewriting that different ways, they usually don't. You'll pretty much see it just like that. Yeah.
So for the c squared plus a squared minus b, I mean c squared equals a squared. Does it matter what order that goes in? Can you have it like
You have to have it in that order.
in that order?
Yeah. Yeah. If you don't do it in that order, what will end up happening is you'll get imaginary numbers if you switch it. So you know pretty quick something's wrong when you start getting high in your answer. Yeah. Okay. So any other questions on that one? That's pretty much the goal every time. Find A, B, and C, and then fill A and B into the formula. But they'll give you different information to start. This was very straightforward. They gave you the center, the focus, and the vertex. That's pretty much the most basic one you can have. Okay, this one, kind of the opposite. So now there's the equation. I want you to tell me the center, the vertex, focus, which way the major axis goes, all the important stuff. Okay. This kind of problem starts out the same way. Find A, find B, and find C first. Okay, so looking at that equation, anyone think they can tell me what A is? You kind of work backwards because it's not written there, but you'd have to think what number would you have, kind of, I can't tell you. Yeah, 5. That's A squared. How do you know? A is always the bigger number. Okay, so you look at the bigger one, and it must have been 5 squared. How about B or C? Which one does the 9 tell me? Yep.
C?
It tells me
Oh, b.
B, right? So the 9 tells me what B is. And what would B come out to? 3. Now, C isn't part of the formula at all. Okay, look back at the, there's no C in it at all. But C is important if you want to describe the what? What pages? What does C tell you? C has to do with the focus. C is the distance from the center to the focus. So if you want to describe the focus, which I am asking for, you have to know C. Okay, how do I get C? Just knowing A and B.
A squared minus B squared.
C squared is A squared minus B squared. 25 minus 9. So 25 minus 9 gives me 16. So what's c in this case?
4.
4. Okay. So now I have everything I need. The bigger number was under x. Okay, again, you don't have to know this yet because I haven't given you the other type, but you will. When the bigger number is under x, that means the ellipse goes in the x direction. It's horizontal. Okay, so it's going to look something like this. So here's your center, major axis, minor axis. All right, where's the center? Because we haven't talked about anything different yet. It's always 0, 0. Now, let's start with the, let's do the foci. So the foci are c units away from the center. And in this case, they're left and right of it. Okay? The major axis is going to have all the important stuff on it. So your foci are going to be left and right. Your vertices are left and right. Nothing is above and below here. That would be the case where it's vertical. Okay, this is not. So how far away are the foci from the center? Four units. Yep. C is the distance from the center to the foci, and they're 4 units left and 4 units right of the center. The center is at the origin. What would be 4 units left of the center? And 4 units right? 4, 0. I guess technically if you wanted, you could have done this. Plus or minus 4, 0. But that's fine. Vertices. So we've got, let me just write everything down. So we've got center. Oh, major axis, I already said it, but we'll write that down too. Vertices. Vertices. Major axis. I think that's all the important things. I think there's just 4: center, foci, major axis, vertices. Yep. Okay, vertices. How far away is the center from each vertex? Yep.
5 units.
Yep. 5 units. So we need 5 units left, 5 units right. What would be 5 units to the left?
-5, 0.
And to the right?
5, 0.
0. Major axis, your 2 choices are horizontal or vertical. Which one is this?
Horizontal.
Yep.
Horizontal.
Yep. Because the bigger number is under x, so the major axis goes in the x direction. So major axis, horizontal. And that's all the stuff you have to say. Okay, so 4 things you have to say when you discuss an ellipse. Okay, any questions on how we figured any of that out? Okay, so let's look at this one. So this is going to be the other equation of an ellipse. It's just going to be the case where it's vertical instead of horizontal. So the center is still going to be at the origin, but watch what happens when I write the coordinate for the focus. It's below and above the center. It's not left and right. Everything's going to line up vertical now. Above and below. The major axis is going to be the y-axis. And the vertices are going to be below the center, A units, and above the center, A units. And the whole key, the way you know that this is vertical, the bigger number is under y. And if you're like, well, how do I know A is the bigger number? We said that earlier. A is always the bigger number. The relationship between A, B, and C is exactly the same. C squared equals A squared minus B squared. Okay, so 2 types of problems you'll get here. I'll give you some information, you tell me the equation, or the other way around. I'll give you the equation, you tell me the 4 important points. Vertex, focus, center, major axis. I didn't specifically write this, but if the major axis is up and down, then which way would the minor axis go? Left and right. They're always perpendicular. Okay, does everyone have what they need for that? All right. Okay, so this one says 9x squared plus y squared equals 9. Let's compare that to the equation, either this one or the one we had before. Something's wrong here. What's kind of weird about example 3? It's not in the right form. When you write the equation of an ellipse, it's always supposed to equal what number? 1. No matter if it's up and down or left and right, it's always supposed to equal 1. So what could I do? I'd have to do it in all 3 spots.
By 9.
Divide by 9. 9, 9, 9. So now you've got x squared over 1, if you want to write it that way, plus y squared over 9 equals 1. Now it's written the way it should be. Okay, let's start with the major axis. Which way does the major axis go with this one? Up and down. How do you know that?
Oh, the bigger number is under the one.
Exactly. Bigger number is under y, goes in the y direction. Bigger number under x goes in the x. So major axis, vertical. And without doing some arithmetic, I think that's the only thing you can write down. Okay, now we need to know what A, B, and C are. Okay, what's A in this case? Casey? Yes, thank you. I had it backwards in my mind. So yeah, bigger number, take the square root of it, that's A. What's B? Michael, yep, B is 1. Now I still need C, even though it's not in the equation. If I'm going to describe where the foci are, I need it. Okay. And what's the formula? Well, actually, it's right here. C squared equals A squared minus B squared. So C squared, A squared, B squared. Okay, so C is the square root of 8. Any questions on how we got that? Okay, you don't have to worry about what the square root of 8 is. You can just leave it as square root of 8. Okay, so what is something else that's important that I need to describe here? I've got the major axis. I need to describe the
The center, foci, and vertices.
Yep, that's all of them. Center. Where's my center for this one?
0, 0.
0, 0. 0. Vertices. What letter tells us something about the vertices? A, B, or C? A, distance from the center to the vertex. Are the vertices going to be above and below the center, or left and right of it? Above and below. So I'm going to go back up. I'm going to look at A. A is 3. My center is at the origin. What's 3 units above the origin? Yep.
0.
And 3 units below? Yep. So I'm just going to write it that way. Just give me 20 seconds. And the foci. What letter tells us something about the foci? C. They're going to be above and below, just like the vertices. C units above. We could just write it this way. 0 square root of 8, and C units below, negative square root of 8. And that's all you'd have to do to describe it. Okay. Any questions on that? It's not too bad once you get used to it. Okay, so take a second and see if you can work on that for your own. Just if you get stuck, we'll go over it. But see if you can find the equation where the focus is at 0, 2, and the vertices are at 0, plus or minus 3. Okay, when you look at this one, what didn't they give you this time that usually we've had?
The center.
They didn't give you the center. But where, if you find the location of the center, how does that relate to the two foci?
It's the center of those two.
It's right in the middle of them. So if you want to do a quick sketch, the vertices are up 3 and down 3. You should already know where the center is based on just that too. There's one vertex that's up 2, but there must be another vertex where, even though, or another focus, but they didn't say it.
Down 2.
There has to be one down 2. So there's F1, F2, V1, V2. Remember that the foci are always inside the ellipse. Okay? If this is your ellipse, the foci are 2 points inside.
The vertices are on the outside.
The vertices are on the outside.
So the center of that one should be 0, 0.
The center is 0, 0. Yep. Now we can find A and C. What's the distance from the center to the vertex? 3. So the center is at the origin. The vertex is 3 units above and below. What's the distance from the center to the focus? 2. So one more thing we need. Okay. What's the formula to find B? C squared equals A squared minus B squared. So negative 5 equals negative B squared. You can just cancel the negatives. And really, you don't even need B. You need B squared. Okay, but if you want to write B, it's the square root of 5. Okay. So every equation for an ellipse starts like this. X squared, y squared equals 1. You just have to decide where to put the bigger number first, and then what it is. So bigger number under x or under y. Yep.
Let's go back up for a minute. Oh, like a little bit. But, thank you.
Nina?
Oh, can I say that?
For now, can you just tell me where the bigger number would go?
Why?
Yes. Look at my sketch. Everything is lined up vertical. That means the major axis is vertical. If you want that to happen, put the bigger number under y. A squared is the bigger number. So 9 goes under the y. B squared goes under the x. So what's B squared?
5.
5. And that's your equation. It's a little different because they didn't give you the center, but we know the center is halfway between the vertices. So it was at the origin. Any questions on that one? So once you know what you're doing, there's not really a lot of calculations. It's not like a 50-step process. It's one equation we had to use, and that was it. That was all. All right, so circle. This is the only slide we're going to talk about circles. Circle is really a special case of an ellipse. It's where the numbers in the bottom of the fraction are the same. Doesn't matter if you call them both a squared or x squared, it doesn't matter. Okay, so if you ever end up with a situation where both numbers come out exactly the same, which won't happen in ellipses, then you have a circle. And usually when they write the equation of a circle, they go like this. Times a squared, times a squared, times a squared. They multiply everything by a squared. So that way when you write the equation of a circle, there's no fraction in it at all. That's just normally how they do it. And did anyone have a guess what this A would be in a circle? It's something special about the circle. It's the radius, and that's why a lot of times they use R. So if you had x squared divided by 12 plus y squared divided by 12 equals 1, that's a circle with a radius of 12. And that's all I was going to mention about circles. Any question on how an equation for a circle would compare to an ellipse? Just the same numbers in the bottom, that's all. All right. Okay, so last thing we'll look at is what happens if we shift the center. Okay, so note the center is not at the origin anymore. Now the center is going to be at the coordinates h, comma, k. I think I wrote this down, but in your packet on page 394 is a formula. And if you erase the h and the k, it looks exactly like what we just did. X squared over something plus y squared over something equals 1. All you have to do is put a minus h and a minus k in the numerator, and that allows you to shift the center anywhere you want. Now, using kind of what I showed you before, how do you know this major axis is horizontal here? Even if I didn't write it up above. Exactly. Whatever a squared is under, that's the direction of the major axis. So there's your horizontal. The one below it is your vertical. Only difference, A and B switch places. Inequality is still true. A is always the bigger number, and they're both always positive. And we can still use c squared equals a squared minus b squared. All right, so now when you start out the problem, you're going to want to write down 5 letters and find out what they all equal. A, B, C, H, K. So five things you have to find. Did I write the page number? Yeah, it's all on page 394 in your packet. Now, if you look at the packet, you're going to notice that they do this. B squared equals a squared minus c squared. That's the same thing. It's just moving things to the other side. It's kind of like if I write distance equals rate times time, or distance divided by time equals rate. Those aren't different formulas. You just move stuff around. Okay? So I would suggest just going with what I'm giving you in the notes, because if you try to look at the packet in the notes, I think it's confusing. I tried to write it the easiest way for you. Okay? So just go with what I give. Okay. So let's find the equation of that ellipse. On the test, I'm not going to put this box here to remind you what you need to find. You just have to remember, oh yeah, find H, K, A, B, C first. Okay, let's start with H and K. Those are the easiest two to find. Anyone tell me what H is in this case?
Horizontal.
So I'm looking for a number.
2.
How much?
2.
Yes. Yeah, the center is h comma k. So h is 2. And the other coordinate in the center tells me k. Other than that, that's the only extra step in this problem compared to anything else we did. The rest is the same. Okay, A is the distance from the center to the vertex. If it's too confusing to look at the numbers, you can always draw it out. The center is right 2, down 3. Your focus is right 3, down 3. Right 3, down 3. I'm going to mark that as the focus. And the vertex is right 5, down 3. And of course, there's the ones on the other side as well. It's symmetrical. So let's start with distance between the center and the vertex. How far apart are the center and the vertex? 3 units. Yeah. There's your center, there's your vertex. 1, 2, 3 units. All right. A is 3. C, the distance from the center to the focus. How far apart is the center and the focus? 1 unit apart. Just look at those numbers, 1 unit apart. Okay. In order to write the equation, last thing I need to find is what letter? B. David, what's the equation again to find B, and it starts out C squared?
A squared minus B squared.
Yep, A squared minus B squared. So C is 1. A squared is going to give me 9 minus B squared, and then solve for B squared. And really, again, you don't need B. If you want to write it, you can, but the formula, you're going to have to square it, so B squared is 8. Any questions on how we got those 5 numbers? So as far as arithmetic and calculation, that's it. That's all you're going to do for calculations. Now we just fill it in. So it's always going to be x minus h squared, y minus k squared. Let's just start with that. X minus 2 squared plus y minus k squared. Now, I said it was y minus k. Why did I put y plus 3?
Because 3 is K.
Careful, 3 is not k.
It's minus or minus.
Right, it's minus and minus. Yep. Because k was negative 3. And that's always supposed to equal what number? 1. So now we just have to decide where a squared and b squared go. Look at my points. The major axis is going to go right through them. So is the major axis horizontal or vertical?
Horizontal.
Horizontal. That means bigger number should be under x. X is horizontal. So what number would I put under x?
2.
What is it? Yeah, it's a squared. So your 2 choices of numbers here are a squared and b squared. So 9 and 8, those are your 2 choices. 9 goes under x, 8 goes under y. Okay, and that's about as hard of a problem as you can have with an ellipse. Any questions on that? That was the last one. Okay. All right, so homework, it's in the packet. And it's all odds. Okay, 13 to 17 odd. 21. 27 to 31 odd, and 39 to 45 odd. Okay, so take a look at that tomorrow. And then tomorrow we will finish last conic section, which is hyperbolas.